All right, folks. So we're down to the last topic in this class, which is chi-square tests. This is the stuff from chapter 7, and I'm going to start with the stuff from chapter 7.1. And this is chi-square tests for goodness of fit. So just like we finished up recently talking about ANOVA, which was inference for lots of means, we have been thinking about proportions. We've done inference for a single proportion, we've done inference for a difference of proportions, and now we're essentially going to do inference for many proportions at once. Just like ANOVA, we're not going to be doing any confidence intervals here. We're just going to be doing hypothesis testing. And much like ANOVA, our hypotheses are almost always the same. So certainly the alternative hypothesis is always at least one proportion is different. So this is always the alternative. You can kind of pick what your null hypothesis is. A lot of times it's that all the proportions are equal. So P1 is equal to P2 is equal to all the way out to PK, where K is the number of groups. But it doesn't have to be that all the proportions are equal. It can be any specification that you specify. So you could say, I think that P1 is going to be 0.2 and P2 is going to be 0.3 and P3 is going to be 0.5. That would be fine for your null hypothesis, but your alternative is always going to be at least one proportion is different. As an example, I found this tweet from Sean Taylor. Sean is a statistician, and he's sort of giving it away here in the tweet. He says, we fail to reject the null hypothesis that Taco Bell distributes sauce packets with equal probability. And what he has tweeted is a distribution of Taco Bell sauce packets that he has been given. So he has a certain number of Diablo packets and fire packets and hot packets and mild, and he's saying, I was thinking that maybe there was some difference, but I actually found that there wasn't. So if we were going to write out our hypotheses here, we would say our null hypothesis is that the proportion of Diablo sauce is equal to the proportion of fire sauce, is equal to the proportion of hot sauce, is equal to the proportion of mild sauce. Because I have 4 categories there, that means that I'm saying that I think all of those proportions are 0.25. And then my alternative hypothesis, as always, is at least one of the proportions is different. So Sean's tweet had some raw data that was shown to us in the form of a photograph. So he had 8 Diablo, 9 hot, 7 fire, and 9 mild. And we want to know, that's not exactly the same proportion of each of those categories, but it's pretty close. So just like with ANOVA, we have a bunch of numbers and we need some way to convert them down into a single number, a test statistic, so that we can find a p-value. And the way that we're going to do it with chi-squared, so when we're doing this proportion stuff, is we're going to compare our observed counts from our real data to our expected counts, what we would expect if the null hypothesis was true. So let's think about this with the Taco Bell sauce example. I have my observed data here. I had 8, 9, 7, 9. And then I could think about how many sauces there were total. So I could do 8 plus 9 plus 7 plus 9, which is 33. So if I was trying to figure out how many I would expect in each of those categories, if the null was true, I could do 33 times 0.25, which is 8.25. So if the null hypothesis were true, we would expect to get 8.25 packets of each of these sauces. And again, if our null hypothesis had had different proportions for each of the categories, we could have multiplied by something different, but the expected count is always going to be n, the full sample size, times pi. That's the null hypothesized proportion for each of the pi's. And then we're going to need a test statistic. So this is going to be our test statistic. And it's a chi-square statistic. So chi is kind of like an x, but it's got the loopy first bar. And the way that we're going to compute the chi-squared statistic is we're going to take the sum, so that's what the big sigma means, of this fraction. So on the top, we've got the observed minus the expected squared over the expected. So we're going to add those things all up. So let's think about that for this Taco Bell sauce example. So I've got chi-squared is equal to the sum of the observed minus the expected squared over the expected. And that's going to be equal to 8 minus 8.25 squared over 8.25 plus 9 minus 8.25 squared over 8.25 plus 7 minus 8.25 squared over 8.25 plus 9 minus 8.25 squared over 8.25. So now, as always, we've got lots of arithmetic to do. All right, and then I just need to add all those numbers up, and I get 0.3334. So that's my chi-squared statistic for this Taco Bell example, 0.3334. And then the next thing that we do in hypothesis testing is we find a p-value. And the way that we find a p-value is we use our null distribution. The null distribution is a sampling distribution of the statistic, assuming that the null hypothesis is true. And as always, we have two different ways to find that distribution. One would be using simulation, so that would be randomization in this case. And the other one is using a distributional approximation. In this case, you might have guessed, there's a theoretical distribution called the chi-squared distribution. So I'm going to do this both ways. So I'm going to start with randomization.